We want to evaluate the definite integral, which will require substitution as well as integration by parts. Before we evaluate the definite integral, let's determine the antiderivative or evaluate the indefinite integral. So for right now, we'll leave off the limits of integration and consider the integral of e to the power of cosine t times sine 2t dt. To begin, notice we have a single angle in the cosine function and a double angle in the sine function. Let's perform a substitution for sine 2t. Recall sine 2t equals 2 cosine t times sine t. So this integral equals the integral of e to the power of cosine t times 2 cosine t sine t dt. And now let's perform substitution. We'll also have to perform integration by parts. Because the integration by parts formula involves u and v, let's perform substitution using w. Let's let w equal cosine t. So if w equals cosine t, then dw is equal to w prime times dt, which is negative sine t dt. We don't have a negative in the integrand function, so let's divide both sides by -1, giving us negative dw equals sine t dt. And now let's perform the substitution. Because cosine t is w, we have the integral of e to the w. We still have this factor of 2, and then cosine t again is w. And sine t dt equals negative dw. Let's put the negative out front, and then we have dw. Let's go ahead and write this as the integral of negative 2w e to the w dw, which should look more like an integral that requires integration by parts. So now let's set up the integration by parts, where we'll let u equal negative 2w, which means dv must equal e to the w dw. Du equals the derivative of negative 2w times dw, which is negative 2 dw. V equals the integral of e to the w dw, which is e to the w. Remember, we leave the plus c to the very end. And now applying the integration by parts formula, we have u times v, which is negative 2w e to the w, minus the integral of v du, which is e to the w times negative 2 dw. Because of the negative here, this becomes plus 2 e to the w dw. And now we have a much simpler integral. The final antiderivative with respect to w is negative 2w e to the w, plus the integral of e to the w dw is 2 e to the w plus c. We need to be careful here, though. We want the antiderivative with respect to t, not with respect to w. So now we substitute cosine t for w, which gives us negative 2 cosine t e to the cosine t plus 2 e to the cosine t plus c. So this is the antiderivative we will use to evaluate the original definite integral. And I've already set some of this up on the next slide. Again, we have the antiderivative at the top in blue. Going back to the original definite integral, we now use the antiderivative without the plus c and determine big F of pi divided by 2 minus big F of 0. So here we have big F of pi divided by 2 minus big F of 0. Recall cosine pi divided by 2 equals 0, cosine 0 equals 1. Big F of pi divided by 2 simplifies to negative 2 times 0 times e to the power of 0 plus 2 e to the power of 0. And then we have minus big F of 0 simplifies to negative 2 e to the first plus 2 e to the first. Notice for big F of 0, we have the sum of opposites. The difference simplifies to 2 minus 0, which equals 2. The given definite integral is equal to 2. I hope you found this helpful.